Okay, Assalamualaikum warahmatullahi wabarakatuh. We'll continue our second session, 2.2, with Santander speed evolution. Okay, we're going to do the Santander speed evolution, which is also a two-dimensional horizontal case. And in this second case, we will run a bit much more complex than the previous case when they use the rectilinear, but on this case, we're going to execute the case on the curvi-linear grid, and it concerns the speed L Puntal. I'm not sure is it Puntal or Puntal, located in the Bay of Biscay, which is the entrance to the port of Santander in Spain. Okay, so the morphological response of a speed during a severe storm. Severe storm meaning here the wave height is quite high. We can check it in the wave spectrum file, and we can work on the following assignment. So for those who do not know what exactly is speed, here is an example of a sand speed where it being influenced by a longshore drift, and it's not connected to the other end of the bay. So basically just bringing all the residue, and the residue then end up being a sand speed here. And it's be quite different from a tombolo with connect to an island or a breakwater. Okay, and this is the satellite image of the speed, and this is the area of the Santander. And you can see here the Puntal here, where we have the longshore current coming in and bringing all the sedimentation, and it ends up here. But what happened when there's a severe storm? Thus, the speed will be affected by the erosion or by the higher wave height on water level. If climate change happen, the rise of the sea level, what will happen to the speed? That's what we wanted to do in this session. Okay, as usual, I have given you the folder that contains all the input that you need, called Santander folder. In this one, you will have the parameter.txt file, the depth file, the grid file, and also the land boundary file. And why there's specifically a land boundary file here, I will explain that later to you even further. And then again, is the run model.batch, where you can have a click and it will run about 20 minutes. But again, have to make sure you can right click and edit. Check first, either you call your executable.exe file. So make sure that you have the correct path. If not, you can try to change the path to the correct execution file of XBeach. So if you have any answer, you can just ask me inside the Google Classroom. Okay, and then we're moving to the second question. Inspect the grid file. Where are the original coordinates of x and y? Observe areas which the grid covers compared to the total land boundary. Okay, I guess you can open your grid and bathymetry of Delft 3D. Here you want to check the grid file, so we click on the grid, and then we open attribute files, open land boundary. Okay, then I go to the Santander file. Okay, so basically, if you doing this from scratch, you go to the Google Earth, you should have this land boundary file. And because of this the boundary that you want to cover is quite big, that is the main reason why you need to use a curvilinear. Okay, and then from the file, we import the grid file. So basically, this is the area that you wanted to cover, because you want to make sure that it covers the whole uh, water area, the spit area where the water coming from, and you do not want to uh, do not want to consider the effect of others, because this is the mainly where your input should comes in. Okay, and you want to know where is the original x and y. So view and line with dots and m and indices. So it's supposed to be grid line and m and indices. Okay, so it's going to be a bit heavy, I know. So so just want to make sure that you have the coordinate at the right place. So I'm guessing, yeah, so it is here, the original 1.1 is over here, 1 is over here, and it basically facing the right way, and it should be in offshore seaward. And then I just going back because it's quite heavy. So basically you can answer that question based on that. Okay, and then the next one, number 3, open params which you specify model inputs file and setting. Check the number of grid points in x direction and y direction. How many directional wave beam are defined and what is their width, theta min, theta max, and d theta. So you go to params, edit with Notepad++, and all the answer should be under the grid parameters. And here, the grid form using Delft 3D, X file, Santander UTM.grid, and then depth file here, theta min here, data, and theta naught. So you have to also answer with what kind of convention, special grid convention that this case use is either nautical or Cartesian. Okay, you can check your grid file here by using Excel file if you want to know how many point that it used. So now I'm not going to show it here. How many wave condition do we apply in this simulation? What is the offshore mean wave condition? Does the surge level change in the simulation? Okay, so the wave condition, you go back to the parameters, the wave boundary condition parameters. You can also refer to the this instead here show you is in stationary, but the wave spectrum boundary condition show you the wave spectrum that the case used in order to generate the storm, the Jones swap. Okay, the mean. So you can open your Jones swap. So this is the wave height of 11 meter and the main angle at 340 degree and the spreading at 20 degree. Okay. The surge level. Where is the surge level? If you go to the params meter under the tide boundary condition, it only use tide location of 1, meaning that at every corner it's interpolate only 1 tide. And if you want to confirm that, you can check the water level, which is the search dot text. You text. So this is the time, and it is the level. So only one location, the length. If you want to add type location equal to 2, or to 4, then you have to add another column. First column, second column, third column, in this case. So that's answer the search level change in the simulation. And then, number 5. In this simulation, the grid is specified in Delft format. Open RFC grid in the Delft and use the brief tutorial to read the grid. Does the grid resolution vary? In longshore direction, what are the minimum dx and dy? Okay, you go back to this grid. Okay, you just want to make sure, because you're using curvilinear, you just want to know, if you go to one corner, you just want to measure the cell. Does it have the similar length, the dx and dy? Okay, one way to do it is that by using this function called move anchor. Just click it. Okay, and then go to one corner of the grid and then press keyboard A. So this mark will come out, and when you move away the cursor from the mark, the distance here will come out. So this is the 0 point, the basic point. So moving further away from the mark point, you have this distance. So if I move to this point, it's 189.3. So I move the cursor back. I press A here. So from here to there is 181. From here is 146, meaning that the curvilinear doesn't have a similar grid size. So if I go a bit to the middle part, I push A. So here to here is only 61 meter. Looking at this distance meter. So click back to enable to disable the function, and you can already answer the question number 5. And then question number 6, inspect which area is the non-erodible layer. So if you notice here, inside your folder, in Santander folder, there's a nebat.dep. So what does it refer to? Go back to your parameter, find the NE layer, non-erodible layer is equal to nebat.dep. So you know that the non-erodible layer is defined by similar file with depth file called the nebat. So go open your quick in, call the grid file, Santander. Okay, and then you import the depth, the nebat. Okay, so this is all the non-erodible layer of the case, which is quite interesting because the only thing that erodible are only the spit here. It should be a spit here if you compare it with the original grid. And view grid on a depth, color, number. Okay, if I zoom it a bit, then you realize the non-erodible structure is denoted by 0, represented by 0 meter, and other than that is 10 meter layer, meaning that the other area can eroded by 10-meter layer, while the non-erodible structure 0 is assumed represented by 0. Okay, and this tender speed is completely erodible. Okay, because they wanted to see if there's a storm, what will happen to the speed only. They want to focus on the speed. The rest will be non-erodible. And then inspect the bathymetry. What is the height of the speed? Does the speed height vary? What morphological storm impact do you expect given the hydrodynamic boundary condition and the speed topography? I think you can do this one on your own, the analysis on your own. You can open the quick in and you can go one by one, check the height of the speed, and you can do a hypothesis. If the height of the surge and of course the wave height is 11 meter, what do you think will happen? And further down there will be an additional assignment. If you change the wave height and also the wave angle, what what do the impact, does it give a bigger impact to the speed topography? So I think that you can play around with the parameters. And what is the simulation time? This one also you can check with the param, the t stop here. Where's this t stop here? 23,760 with more fact 10. So I think you can calculate the hydrodynamic time and also the morphological time. Okay, then moving on to number 9, inspect the model results and make an animation of the short wave height and the water level. Okay, if you open your quick plot, you may read the output file .nc .netcdf. You open the file and then you can make the animation of short waves. They are set the output, bed level, water level, wave height, Eulerian velocity, mean wave angle, sedimentation, and total bed level change. Where do all these output coming from? It's from your params here, your output variables. All these ZP, ZS, this is these are the thing that you have you say that you want it as an output, and XBeach put everything here as the output. Okay, and then for example, I check the water level. Okay, and he said here, the manual said here, the water level simulation set the color limits manual. So you can set the color here, automatic or manual, between minus -0.5 to 4.5. Then you can either quick animate it or you can just quick view the very end of it, the last time step. So it's the final time step. Or maybe it's quite difficult to see here, so I just try to quick animate. This is the water level, meaning that the surge. Okay, the water level, which is the red color, shows higher water level. You can see the water coming from this area because this is a nautical convention and the wave angle coming from 340 degrees. You can see the red color here. This legend only show for the water level, so do not mistaken it for the land boundary. And this area is erodible. This is non-erodible. You can see it coming. and the longshore current push in. So you can look at it, and then look at the mean flow field. Plot the flow field in color vectors. Where are the flow velocity highest, and what is the direction of the flow? Is is there a longshore current present, and what is intensity? So we can go for the Eulerian, yeah, because it's a flow as a bulk flow, so it's a mean flow. So we use the Eulerian. It's not a Lagrangian. Color vector. So you just click the color vector magnitude. You can use, if you want a vector style, rooted line, vector scaling, and then you click animate it. So because it is a color vector, the vector that give you this color give you a high number of magnitude, meaning that higher velocity. As you can see here, is the velocity getting higher. I open it bigger, a bit bigger, so you can have a better look at it. So we can actually see when the storm start hitting the land, the velocity increases and the circulation start happening here, and all the movements start going into the speed area. And because of the channel is getting shallower, for the passage is getting smaller for the mean flow, so you can see it hitting here, the obstacle here. So the velocity is higher here, and of course higher here. And when the storm is getting extreme severe, it getting passed through the speed, the magnitude. And definitely when this velocity is higher, it definitely will um, involve the turbidity, the turbulence, that of course will affect the rate of erosion, the position here. So it's very interesting. You know what happened here is very high intensity here of the velocity. It's very intense here. So you're going to stop there, and you can compare it, your result, of course, with the cumulative sedimentation. Sedimentation, and you plot the limit as 3 and minus 3. Click animate it. So before this, you already know the water level, you already observe the water level, and then you move on to observe the velocity of uh, the storm with, with height of up to 11 meters. And then you can relate both of the scenario and phenomenon to this accumulation of erosion and also deposition. So we have to wait a bit just to let you guys see the effect of sedimentation. Just be a bit slow. Okay, I just want to do a quick view at the very end, the final step. So you can have a look here. This is the final step. So you can see how some part are eroded and then being deposited away from the speed, meaning that the velocity push all the sediment and deposit it somewhere else because of this high intensity here you have observed from the velocity. Okay, so it's very interesting. You can have further analysis, and that is the reason why you can answer number 12. If you have time left, feel free to. but you have to do it anyway. You can change the spectrum parameter, set the S 200 and set 2 respectively, and you can make animation to see what happening to the size of the wave group happen if you change the size of the wave group, the spreading, the axis is spreading, and then you can change the direction of the storm and associated storm wave. This is the one in the John swap, and you can lower the surge level and look at the difference in morphological response. I mean that if there's no sea level rise or tidal is if it's happened during the low tide, what will happen? So have fun doing it, and I'm looking forward to see all the conclusion you made for the case of Santander speed. With that, thank you very much. Have a pleasant weekend.